Hello, class. Whew. Today is section 310 and 311 for Algebra 2. We are learning about imaginary numbers and I. So when squaring any real number, and these are all different examples of real numbers, pi always throws people, but let's remember pi is 3.14, like it is a real number, it's not a variable. You always get a real number. So when you square a real number, you get a real number. As such, we can only solve x squared equal a if a is greater than or equal to 0. So if a was negative, we were not able to figure it out because there was no negative number, no way I could square something, multiply it by itself, and get a negative. X squared equals 8 has two solutions, so let's think this through. We take the square root on both sides. Absolute value of x equals square root of 8. We could simplify square root of 8, or we could not. But the solutions are going to be plus or minus square root of 8. So the positive and negative square root of 8. To solve x squared equals a, if a is less than 0, mathematicians invented a new number that's not on the number line. The new number was invented as a solution to x squared equals negative 1. So if I have x squared equal to negative 1, I'm going to go ahead and solve it over here where I have space. I take a square root on both sides. Square root of root is going to be absolute value, and this is square root of negative 1. So that means x would equal plus or minus the square root of negative 1. And they decided to name the square root of negative 1, that whole thing, we're going to call I. So this would equal plus or minus I. So square root of negative 1 is defined as the imaginary unit, that's what it stands for, and is denoted by I. So the solution to x squared equals negative 1 can be written as plus or minus I, which we already did. I always make mine look kind of cursive so that I can tell apart, an I from a 1 easier. So be real careful. Any number with I is called an imaginary number. You don't have to, I just find it helps, especially because you're all trying to read my handwriting. Now we can solve equations of the form x squared equals a, where a is less than 0, which means we would be able to solve all of them, right? And normally they're going to say something extra. If it just says solve, we're going to assume we can't have square roots of negatives, but if they say something like solve over the set of complex numbers, or solve and imaginary numbers are okay, something like that, right? That's when you know you're going to be able to use those kinds of numbers. So for the first example, I want to take a square root on both sides, and then the square and the root means I have an absolute value. On the other side, I know that negative 9 is negative 1 times 9. So I'm going to make this the square root of negative 1 times the square root of 9. And I still have absolute value x. The square root of negative 1 is an I, and then 9 is 3. So I'm going to write this as x equals plus or minus 3i. Now, as far as I'm concerned, it's good to see this once, but you can go directly from here I do want to see the square root instead. Let's see how your work can be shortcutted. We'll do it on the side over here. So as far as I'm concerned, you can square root both sides. We can get absolute value of x equals square root of negative 9, and then we could write plus or minus 3i. I don't need you to do all this work, but I think it's important for you to see that, right? And I don't even really need to see this step so much. I think it's important for you to see how can I write negative 9 like that. And that's because the negative 1, this by definition is an I, and the square root of 9 is a 3. That's how we can do this. On the next one, I want to go ahead and take a square root on both sides, and I get an absolute value of x. And again, this is like the square root of 11 times the square root of negative 1. This time do it in the opposite direction, which is like square root of 11 times I, right? So the issue here, I don't like having the I at the end because it's hard for me to tell if like the root goes over it or not, right? We're just not really sure what that person's writing. And so we're going to choose to write the I in front of the square root. So it's going to be x equals plus or minus I square root of 11. So it's a little bit backwards from what we normally would see. Usually we would think about like having an x or something at the end, but because we want to make sure that the I is not part of the square root, we're going to write it in front. So imaginary units raised to power, so I is just I. I squared, well, let's think about what I squared would be. I squared would be I times I, and I is equal to the square root of negative 1. So it would be the square root of negative 1 but then squared. The square and the root would cancel, so I squared is going to equal a negative 1. Now let's think about I to the third power. I to the third power is going to be an I squared times an I, because 2 plus 1 would give me back third power. So I know that I squared is a negative 1 times I would just be a negative I. So I to the first power is I squared is negative 1, I to the third power is negative I. Now let's think about I to the fourth power. So there's different ways of doing this, but I think the easiest would be to say, well, it's I squared times another I squared. So I squared is negative 1. Another I squared is also a negative 1. Negative 1 times negative 1 is a positive 1. Now let's see what happens if we do I to the fifth power. That's going to be I to the fourth times I, right? Because 4 plus 1 makes the fifth power back. I to the fourth is 1, and I is just I. We are back to I. So this is my I to the fifth power is I. And then you can see if we figured out I to the sixth, that's going to be I to the fourth times an I squared. That's going to be a 1 times I squared. So it's just going to be the same as I squared. So it's kind of like this circular thing here, right? Where for the next power, it's just going to keep going back and forth. It's cyclical. It's going to change between those 4 values. We're going to go ahead and play around with some simplifying here. So the first one, I'm squaring. Remember, we distribute square to everything. So I'd have I squared, and I'd have the square root of 12 squared. Well, the square root of 12 squared is just 12. And then I squared, I might have memorized already. I might have to look at it. But I squared is negative 1. So negative 1 times 12, which is a negative 12. On the next problem, my square and my root just cancel. Even though it's a negative, it's fine. It's going to be negative 15. On the next one, I to the eighth power. That's a tricky one. So this is going to be I to the fourth times another I to the fourth plus I to the third. I could look at my chart and get negative I. So I to the fourth is always 1. So 1 times 1 plus negative I is going to be 1 minus I. So let's go ahead and turn our page and look at the next set. We're going to be working with complex numbers. Complex numbers are going to be a combination of real and imaginary numbers. So the complex number a plus bi, a would be the real part. So notice over here, a doesn't have an I with it. It's just a letter by itself. But b is being multiplied by I. So that's going to be the imaginary part. We can plot these not on a normal number line, but we can use a coordinate plane, and we call it the complex plane. So the way we're going to go ahead and graph these is we're going to take the real part. So like for this first one, 2 plus 2i, the real part would be 2. That's going to be our x value. And then the imaginary part, the 2, that's the coefficient there on I, that's going to be our y. So we're going to plot it like the ordered pair, 2, 2. So it's always real, then imaginary. So 2, 2 would be right here. I'm going to label it A. On the next one, same idea. X is going to be negative 1. Y will be negative 3. So negative 1 comma negative 3. That's going to be down here. So we're going to label that one B. So check your understanding. We should add some words to the directions here. It says solve the quadratic, but it really should be saying over the set of complex numbers. If it just says solve, it's totally cool to be like, sorry, I can't, no real solution. But if we say complex numbers, that tells you that you could get I in your answers. So be really careful about directions and ask if you're not sure, because sometimes we make mistakes with directions too, like on this one. So the first problem, I want to subtract 7 on both sides because I want x squared by itself. X squared is going to equal negative 12. Now that I have x squared by itself, I can square root both sides. When we have a square and then a root, it's always absolute value. And 12 I can simplify because 4 is a perfect square and it divides into 12. So I'm going to write the square root of 4, square root of negative 1, square root of 3. So x is going to equal plus or minus. The square root of 4 is a 2. Square root of negative 1 is I by definition, and then root 3 is going to stay root 3. So we really want them to be like number, then I, then square root. But if you get them mixed up, just fix it on the next step. Next problem, I want to subtract 11 on both sides. So 2x squared equals negative 48. Then I'm dividing both sides by 2. So that x squared equals negative 24. Now that x squared is isolated, we're going to go ahead and take the square root on both sides. So now I have the absolute value of x equals, and then I'm going to work on simplifying again. So 4 divides into 24, so I'm going to make it square root of 4, square root of negative 1, and it's 4 times 6, so square root of 6. So x is going to equal plus or minus 2I root 6. So remember, we're trading in that absolute value gets traded in for the plus or minus, and I'm really trying to make it just number, right, whole number, then the part that's left over in the root. The last one, I need to get my squared quantity by itself first, so we're going to divide both sides by 2. So now I have the quantity x minus 2 squared equals 9. So now I can go ahead and square root both sides. So take a square root, and again, when I have a square and a root, I get an absolute value of x minus 2 equals 3. So let's go ahead and write down our two equations to solve. The first one is x minus 2 equals 3. The second one is x minus 2 equals negative 3. So I knew to write two equations for this one because x minus 2 is an expression, right? It's not just like the last one where we had only an x inside my absolute value. So I have to do some more solving. When we add 2 on both sides, we get x is equal to 5 or x is equal to negative 1. And they're both going to work. 5 minus 2 would give me a 3 squared. Negative 1 minus 2 would give me a negative 3 squared. But either way, if I square 3 or negative 3, I'm going to get a positive 9. So both are going to be solutions. We got a little bit of simplifying at the end. These ones I think you should actually try on your own. So go ahead and pause the video and then come back and check. So our first one, remember, distribute your squares still. So we have an I squared, and then square root and square would cancel. We'd get 17. I squared is negative 1. So we have negative 1 times 17, which is a negative 17. On the next one, you could just go directly to the answer, but I was just going to write that this is the square root of 36 times the square root of negative 1. The square root of 36 is 6. Square root of negative 1 is I. Again, you could go directly from root negative 36 to 6i. It is okay to not show work on those. I just want to make sure that you understand how we're getting that. On the next one, square and root cancel, so my answer is just negative 20. And then on the last one, I'm going to have to play with these a little. So I to the 6th is I to the 4th times I squared, because 4 plus 2 makes 6. And then I cubed, I could go back and look up. And so this is a 1 times a negative 1 minus I cubed is a negative I. So I'm going to get 1 times negative 1, that's negative 1. And then minus a negative I is going to be plus I. So lots of information going on today, right? We're learning about imaginary numbers. We've got all these weird exponents, so that's one thing. We can go ahead and we can solve things now where x squared equals to a negative. That's another big main idea. We've got these graphing, where we're graphing them on the complex number plane, complex graph. Just kind of this cyclical idea of how powers work. So many things going on today, lots of information. I hope it's interesting to you, though. Mathematicians really enjoy imaginary numbers. They're just kind of cool. All right. If you have any questions, please make sure you ask.